Okay, so multiplicity of zeros. Now, what does that mean? It means how many times a zero appears. Zeros are the same thing. They're like x-intercepts, that kind of thing. Solutions. Now, what does multiplicity mean? Well, how many times a zero appears? So, for example, if I have x plus 1 to the 1 power, we would set that equal to 0. X plus 1 equals 0. X equals negative 1. And he only appears once, so we say he is multiplicity 1. And if I would say x plus 1 squared, he's x plus 1 times x plus 1 equals 0. I get x equal negative 1, x equal negative 1. We would normally just write x equal negative 1 because there's two of them. But because there is two of them, this is multiplicity 2, because he appears twice. And if I had an x plus 1 cubed, this is x plus 1 times x plus 1 times x plus 1 equals 0. So x equal negative 1, x equal negative 1, x equal negative 1. So again, you notice we'd only write it once, but because he appears 3 times, there are 3 factors, he appears 3 times, he's multiplicity 3. Now what you also notice is the number of times it appears is the power on the factor. Once, it only appears once. The power is 2. The parentheses appear twice. Power is 3. Parentheses appear 3 times. It tells you how many times the 0 appears. Then you might ask yourself the question, or not, self, why is that significant? Well, we're going to break it down into 2 columns. One's going to be polynomials. The other one's going to be rationals. Because it's going to hold true, they're going to be zeros. Zeros of the polynomial, zeros of the denominator. It's true no matter what. It's going to basically give you a key to the behavior. Now I'm going to have, and you can see what's going to happen, I'm going to put 3 things across here. I don't think I've got room for 3 things down, but I'm going to smush 3 things in across. I'm going to look at each one of these factors as to how it would graph. X plus, well, let me move this up a little bit, because I'm going to need the space. So polynomials, rationals. X plus 1 to the 1 power. And then we're going to look at x plus 1 squared, and then x plus 1 cubed. So that means there's going to be three columns. X plus 1 to the 1, if I go to graph it, it has a 0 at x equal negative 1, and he is a line. Here's my 0, and he's a line. Now you're going to say, well, what's significant about that? Now remember, this is multiplicity 1. Well, if I look at multiplicity 1, the line crosses the x-axis, first of all. And when it crosses the x-axis, on one side y is negative, and on the other side y is positive. So y is negative, change y is positive. So y changes sign. And that's where on that number line that you saw on that key to the worksheet we did on Friday or Wednesday, whatever day we did the worksheet, Wednesday. On Wednesday there was a C on the number line. That says there was a change. Y changed for negative to positive, or positive to negative. You can go the other direction as well. Now I can put my line down here. And x plus 1 squared. Now what does it look like? Now I have to be careful because I'm dealing with negative 1. Dang it, I did it again. I'll put the horizontal in first. Then I'll put the vertical, and then I'll be a happy camper. Because negative 1's on this side of the number line. There's my 0. What does x plus 1 squared look like? It is a parabola that opens upward whose vertex is right here. That's what it looks like. So I have a parabola, P-A-R-A-B-O-L-A, and what does the parabola do? It touches the x-axis. Now what's significant about that? Well, y is positive, and it stays positive. So multiplicity 2, y is positive, it stays positive, y, the sign on y, does not change. And I normally mark that with an N for no change. Now, what does this guy look like? I want to draw my horizontal again so I can get my vertical into place. And negative 1. Now, what he looks like an S curve. So he is an S. He crosses the x-axis, which means on one side y is negative, and then it changes to y positive, because he crosses. So y changes sign, and we'll put a C there for change of sign. Now, what does this mean to us? So, excuse me, multiplicity odd, multiplicity odd, y changes sign. The graph crosses the x-axis. So y changes sign. So odd is 1 and 3. X plus 1 to the 5th looks like this. 7th looks like this. 9th looks like this. So 1, 3, 7, 9. If you've got an odd multiplicity, then across that 0, y will change sign. Plus, minus, minus, plus. even multiplicities, which would be 2, 4, 6, 8, and so on. By the way, odd would be 1, 3, 5, etc. That's odd multiplicity. Y does not change sign. We're talking about the behavior at the zeros. And see, our life has been all about zeros, right? Take the derivative, set it equal to 0. You're finding the zeros. Well, what's that mean in terms of the rational functions? Well, if I'm trying to look at the rational functions, and I look at 1 over x plus 1, he's a rational function. X can't be negative 1. This is a vertical asymptote of VA. Now, if I want to take a look at the graph at negative 1, it's a VA, and what the graph looks like is this. What the graph looks like. That's his nature. Well, what do I notice? Well, first of all, if I look at the denominator, I'm going to take this guy and break him in half, because there's 2 of them. The other one is 1 over x plus 1 squared. The denominator can't be 0. X plus 1 is the denominator, can't be 0. X can't be negative 1. The power on x plus 1 is 1. This is multiplicity. 1. Now, what does multiplicity 1 look like? Well, if I think about it, multiplicity 1. If I look to the left, y is negative, and it's changing to y positive. So you have a change across the VA. So y changes sign across the vertical asymptote. Now that would be true of cubes and all the rest of it. So if the VA is odd, change sign across the asymptote. But what it can't be is a maximum or a minimum. Now if I look at x plus 1 squared, still x can't be negative 1, so it's a VA. And again, if I draw the graph, and negative 1 is the VA, and this is what he looks like. That's what he looks like. Now, what do I notice? Again, x plus 1 squared can't be 0. X can't be negative 1. The power on the factor is 2. He is multiplicity 2. So what do I notice? Y positive stays Y positive. Y does not change sign across the vertical asymptote. So it acts just like a zero of a polynomial in terms of the change, no change. What we want to do, however, is to make this a useful tool. And if it weren't a useful tool, I wouldn't spend the time doing what we're doing.